Hi folks, what I'd like to look at right now is how to find limits using a table of values. And this is great because once again, this will visually show you what the numbers are getting close to, not with a graph, but with numbers. And in lots of cases, maybe not this decimal example I'm going to show you here, but in lots of cases, you could ask an elementary school teacher to just look at the table of values and they could find the limit once you've gotten the numbers in there. So here's what we do. I want to find the limit as x gets close to -5. I know that if I actually plug -5 into this function, I get 0 divided by 0, something that just doesn't work. That doesn't give me a number. So I'm going to try and pick out some x coordinates that are close to -5, some that are smaller than -5, and some that are bigger than -5. And I want to see if the y values approach the same thing above -5 and below -5. Here's the numbers I chose. I think these are good examples here. I have a set of numbers smaller and a set of numbers larger than -5. They are getting closer, and they're getting closer by a factor of 10. Here's 1/10, then this one's 1/100th away, and that's 1,000th. So that's really good. The one thing I don't want to see is like the numbers that just appeared up here. Don't just make them 1/10, another 10th, another 10th. 4.9 is not close enough to 5. You need to get closer and closer. This needs to get even a smaller distance between -4.999 and -5. If you cannot see what you're looking for, if you cannot find a limit, then I recommend you pick out even more numbers and just make a bigger table. And it's really easy because when I plug these numbers into my function, I get all these values and I can see, gosh, from the left-hand side, I seem to be approaching this number here. From the right-hand side, wow, I'm approaching the same number. It looks like as I get really, really close. Now, the number here is 0.16667 or 667. It actually turns out that this function, the closer I get, would be about -1/6. Okay? It's getting closer to -0.1666666666666. And if we made our numbers closer to -5, we'd see that. Right now, I'm perfectly fine with you just picking out these values. However, here's the big part. How do you get the values for your function or your y coordinates for this table? And that's where I'm going to jump to the graphing calculator for a moment. We're going to pick out one more example. Once again, if I put 1 in here, I don't get an answer, but I'm going to pick out numbers close to 1, such as these. I'm going to go to my calculator, and the slowest possible way of doing this would be to actually plug the numbers in one at a time. It gives me the correct answers, but it's slow. So that's option 1. Literally, just plug in the function, and everywhere there's an x, put in 0.9. And then after you found that y coordinate, everywhere there's an x, put in 0.99. You'll get a nice table, and you'll see that the left and the right-hand sides of this function are approaching 1. Yay, you have your limit. But here's a couple quicker ways you can do it on your calculator. If you would type your function in to y equals, you can graph it, and right above trace, you can calculate all the different values. You can plug in 0.9, and it gives you a y coordinate at the bottom. You can plug in 0.99, and notice this is a little quicker. I can get these values out fast, and I can even get more precise if I want to. So that's the quicker way. The final way is to go to a table. Right above window is a table set. This has a starting value of 31, and it's moving up by 1. So what I'm going to encourage you to do is if you make a table, ask for the x coordinate or the independent value. Go into y equals, type in your equation, and then go to table just above your graph button. Now, I like this method because I can type them all in at once. It makes it easy to copy. Oops, too many. And I get all my numbers right here in front of me. I'm having a hard time typing, but the table is a